In past weeks, we've talked about rigid data products. There's the Gulf of Mexico data product, which I'm sure you're tired of seeing, um, and how this data set is all the E&P data you could want with exact answers and quantities. Then we talked about representational data products, or our specific product called EBIS, which is more of a cartoon, massive market intelligence, not afraid to hang it off of digitized polygons, helps out with business development. Then we talked about a mashup, which was our global vessel data product. That was taking a rigid data set alongside another vendor's data, marine traffic's AIS positions, looking at vessel positions over time, doing some analytics on predicting urbanization. And finally, now we're going to talk about some novel analytics. So in the intro slides, you saw I listed this product at setld. I listed it as data subscription enhancement service. Lots of folks out there, operators buy data subscriptions from many vendors. setld is one of those vendors. We offer a service at setld to take any vendor's data and render better answers for you for certain business cases. That's what the lab this week has been about, is finding steady oil production and new opportunity in certain older, perhaps forgotten oil provinces. So rather than use a settled data subscription or IHS or drilling info, we're starting to ramp you toward being able to create your own data subscriptions. You've seen the gamut of rigid data products, the full set. You've seen representational possibilities. You've seen mashups. Now we're going to show you some novel analytics using sources like IHS drilling info, settled, P2 Tobin, RexTag, alongside your own data to come up with some business answers. So starting off, we've chosen to provide you with some basins, some production data we got from Utah, and a well header we got from Utah. Providing the links here. A lot of times it's a matter of one of the things you need to learn is what's a good piece of data and what's garbage and gibberish. So these production sets here are good data. You got your pre-84, you've got your 84, 98, your 99, 2008, etc. So we downloaded all of these. We got a well header that we got from here. This here is they've got a Google Drive with file geodatabase with their well header. And then finally, just some basins, open source basins. So looking at production, the main point I'm trying to make to you today is that this data doesn't come down ready to use. And for a lot of people, that's crippling. So they just buy it from a vendor. A lot of times that's fine if you don't have time to postulate certain, when does this need to be updated? Is this source reliable? Does it ever go down? Should I automate it? Should I not? Which pieces do I care about? You don't have time for all that. Buying a set is a decent answer. But if you do have time and you've got a focused area, say I only operate in Utah, it's probably in my best interest to learn a lot about Utah and learn about all the data sources for Utah. So I may as well, what I call swim in the data, learn about the data, learn how to flow that data. Here are the sources. So I took down these CSVs and this DBF from that link I showed you. I then went in and tried to look at the formations that these wells were producing from. And unfortunately, the old production has a different sort of list and had to do a little bit of normalization. They've got abbreviations in the old production, whereas in the new production they spell it out. So you have to do things like this. You have to kind of recognize a problem, solve a problem, understand if you're willing to solve the problem, not be lazy, assess how long it would take to solve a problem, and build a job. So I've built this production loader here, and I wanted to show you that in action. So that job is currently running. It's in a degraded performance state because I'm running it to a file geodatabase. And that's because I need to transport it to you, not because I work in file geodatabases. I would typically run this to an industrial database like a SQL Server SDE. We wouldn't have this sort of problem. What I've got here is essentially I've got the well header, so the oil and gas wells from the file geodatabase, the DOM file geodatabase. I've got the production files. I've got the 84 through 2020 down here coming in, doing certain things to that in FME. Got the old production header here doing certain different things, one of which I mentioned was an attribute value map from abbreviated to new style, trying to match this old production formation call out to the new style production. Once I'm there, I'm doing some various things like splitting the date and turning it into a real date instead of a string, merging up with the well header, determining first production date, determining last production date, adding up cumulatives, adding up first 12 months, last 12 months. That would be in these locations. So this is essentially saying, calculate the last 12 months of oil, gas, and water by API. Merging with the well header, spitting out a flattened set. So this is one row per API with some summed up attributes like oil calc first 12 months, gas calc first 12 months, etc. So those are helpful. A lot of times out of Interdeck, instead of dealing with monthlies, if you notice here, the monthlies for Utah, if I take all of the production they've ever had up till April 2018, is 3.5 million rows. You may not want to deal with 3.5 million rows in your analysis. When this one's all said and done, it's going to come out with about 19,000 different wells, and it's going to have that summarized production information. And what that can offer you, the first 12 months offers you a glimpse into the birth, the performance at birth. The last 12 months is performance at death or current. You have first prod and last prod, so you know how long it's been online. Those are going to be some key attributes in our analysis. So just summing up, this exercise is targeting oil wells that have been producing continuously for at least 5 years. The first 12 months and the last 12 months must be relatively similar. They're seeking a steady state oil production rate, which infers good reservoir presence, but perhaps inadequate completions. Could have been designed for other purposes. For example, in the late 90s, oil was $10 a barrel. Operators were targeting gas. Flat decline curve looks something like this. We're going to look for a variance, 80% to 120% of the curve. This is the FME job to make the base data. So think of it as the data subscription or data product. I showed you this job earlier. It's making the production set. Take the well set, the production set, some pipes, some facilities, some land, lease, some permits, other things, HSE. You've got a data product for Utah. Looking at some background economics, a strat chart, the subsurface, all your understanding your formations. So the objective here is to create a map that can identify the best potential places to drill a horizontal oil well and reap the rewards that may have been forgotten or misunderstood. So essentially we take the flat production, query that for things that wells that have been online for more than 5 years, have a lifetime longer than 5 years. And then we're going to build an FME job to do analysis. You can build your own model using FME, Model Builder, or even just a series of logical steps and exports. Sort of a back to basics approach. Essentially, we're going to, like I said, keep it in range of that decline curve in a straight line. We're going to buffer. We're going to intersect with all the wells, so not just candidate wells, but all the wells once again to see if there's density issues, like not enough room to place a horizontal, or somebody's already done this and drilled a horizontal, so I might not need to look there. And then buffer it up again and do some convex dissolve and convex hull grouped by formation to understand some high-graded AOIs. And at the end, you're gonna do some good cartography work to make your story clear. And perhaps at the end of the day, you've built a screening tool that helps save your G&G and RE staff time, basically pointing them in a direction to go and study something further. And at the end of the day, helping your company save time and money, and perhaps taking advantage of others' misunderstandings or forgetfulness. So here's the analysis we run. Taking the flat production 19,704, you see as we move down through this list, we trim some attributes, we remove duplicates if they exist, they should not. Replace nulls with 0, we don't want to end up with a divide by null. That makes no sense to a computer. Or a null divided by something, makes no sense to a computer. First 12 months, last 12 months divided by 2, find out days on production, calculate a years on, determine an average cumulative oil per year, determine a factor, decide if that factor indicates a relatively flat decline curve for oil. I didn't use this, which is saying that it must have had production in the last 12 months of its existence. It can change the output a little bit. You can try it, hook it up and try it. Producing last 5 years, you can see that the coming out of relatively flat went from 19,000 to 2,700. Producing 5 years outputs 1,100 candidate wells to a points feature class. Buffer those candidate wells by 1 mile. End up with same thing, 1,119. Take those 1,119 buffers and intersect all wells. So this is 36,233 surface locations. Decide how many of the 1119 buffers have less than 10 wells intersected in that 1 mile buffer. In this case, 81 areas. You can change these parameters until they suit you. Also determine that there must not be a horizontal in those 81 areas. In this case, we see that we had 3 areas that already had a horizontal. Buffered by 2 miles, dissolve, convex hull, end up with 41 target areas. Those 41 target areas look like this. Let me zoom to entire picture. So as you can see, the northern Uinta has some target areas, some large target areas, and the Paradox Basin has some clustered target areas. Let's take a look at these. So you can see that the Green River Wasatch is a large target area, a lot of steady oil production, steady decline curve, not much density as far as existing wells. You can see there's a lot of density in the heart of the Uinta, but up here we're not seeing that. So this has come out of our analysis as being a good area to look at. Wasatch, Green River, Wasatch, Green River, and Wasatch. So over here, you could drill a stacked lateral, for example, a multilateral in different depths, perhaps. But this is for G&G reservoir engineer staff to take a look at. Let's take a look at the Paradox Basin, Southern Paradox Basin. And we see that the Ismay, the Desert Creek, and the Ismay Desert Creek are showing up as areas of interest. Once again, a possibility to drill stacked laterals, and you see just to the west of it, very, very dense existing oil development. So as discussed, this is a good screening tool. It's now time to hand it off to the professionals, folks that know the subsurface in these areas. Tweak your parameters, run, rerun, build your models in FME or Model Builder, something repeatable. That way you can tweak a parameter, run it again, get with your folks, decide if it's starting to make more sense. As you can see, GIS can be a game changer, even for GNG reservoir engineering. So hopefully you've learned something from this, and I appreciate your attention, and good luck out there.